Hello, I'm Mark. I am a senior R&D engineer at UniKLasers. First of all, holography is a method of recording 3D images of objects and then later reproducing them. This can be achieved by taking a laser and splitting it into two parts using a beam splitter, and then allowing one part to interact with the object while the other is unchanged. When these beams are recombined, there will be an interference pattern, with the pattern itself depending on the phase changes induced by the object. Therefore, it will contain phase information. This information can be recorded in some light-sensitive media and stored. To later reproduce the image, you take the same laser source, or the same frequency as used for the recording, and illuminate the media. And this performs effectively the same process in reverse, where we end up with a lifelike image of the object. And by that I mean it will have 3D properties and can be viewed from different angles. This, as you can imagine, has applications in a large number of fields. You want a very specific type of laser for this. You want a single frequency laser. This avoids any issues with secondary images being formed. You want it to be narrow line width and high power, which will give a large acquisition area. And you want long coherence length. This will allow for large acquisition times. If you're working on colour or RGB images, you also want very specific wavelengths to create the correct colour balance. There's many applications for this. So there's applications in the museum field and arts, and this can be used for things like taking images of one-of-a-kind artefacts and then reproducing them, allowing for wider distribution. In monochrome, it can be used for more artistic representation. One of the most widespread and adopted applications of holography is in forgery prevention. This is what we have on all our banknotes and some documents, where we have these holograms, which are very difficult to reproduce without the correct equipment. More up-and-coming applications are things like digital data storage, where we have a method of saving data in 3 dimensions. This has the potential for exceedingly high density of data storage. And also because this is subsurface in the media, it has the potential to be quite resistant over time. One of the biggest up-and-coming areas is virtual reality or augmented reality, which for things like wearables, car displays, and this has the potential to be a very large field.